ready. Oh, God. You got it.
Just pour them into the paper towel.
I'm posing.
You guys gotta make sure.
Halfway, right? So that'll be, yeah.
Alright, Ricky, go, go, go.
Yeah. 100.
Okay, you want to bring your paper over your camera?
Yeah.
Alright, subtract this.
252, 152? That's 100.
Right on the money. Sweet. Okay.
No, what do you mean 90?
Thing always has
Where's the gripper thing?
288.40.
I think we're doing it twice, so.
Okay. Now stir. Have the thing over. Yeah.
Alright, it's 58.
Right, so it's time to do some calculations for our specific heat capacity lab. We collected our data for part 1, and so part 1, we had our calorimeter, styrofoam cup in the beaker. We put some ice cubes in the hot water, and the idea is to calculate the heat of fusion of ice. And so we need to know how much energy did the ice absorb to melt for every gram of ice, so per gram. So that we're looking at the number of calories per gram required to melt ice. And so therefore what we need to do is to calculate the amount of energy that's given out by the hot water to the ice. And so the first calculation that we need to do is to determine how much, what was the mass of the hot water. And so we have the mass of the calorimeter at 157 and the calorimeter filled with the hot water at 266. So we subtract 157 from 266, and we will get the mass of the hot water, which is 108.2. So that's the mass of the hot water that we used. Then the mass of ice, 309 grams was the mass after the experiment. So this includes the calorimeter and the hot water that is now cooled down and the ice that is now melted. So the difference between 309 and 266 is the ice. So if we subtract these two numbers, 266 subtracted from 309, we get 43.21 grams of ice. So this is 4 minus 2, box 4 minus box number 2, and this is box 2 minus 1. The initial temperature of the ice was measured in the ice bath at 0 degrees. The temperature of the warm water was 46 before we put the ice cubes in it, and the temperature of the equilibrium temperature, which is after the ice melted, 11.5 degrees Celsius. So we can calculate the heat loss by the warm water. And so the heat loss by the warm water is delta H is equal to the mass of the water times the specific heat capacity times the temperature change of the water. So it was 108.2 grams was the mass. The specific heat capacity is in calories for this part of the activity is 1 calorie per gram degree Celsius, and our change in temperature is from 46 to 11.5. So 46.3 minus 11.5, which gives us a change in temperature of 34.8 degrees Celsius. And so this is the amount of heat. It's a decrease in temperature, which will give us a negative delta H because the energy is lost. So the sign of the delta H is not a measure, is not a representative of the quantity of heat. It just indicates if the energy is gained or lost. So when we do this calculation, we're going to get negative 3,765 calories. And so this is the amount of heat lost by the warm water, 3,765 calories. Well, now what's important to understand is that this amount of energy is not entirely going into the ice cube, because what happened is 3,700 calories was used to do two things. First, it was to melt the ice, which gave us some water at 0 degrees Celsius. But since the final temperature of the experiment was 11, then what happened is some of this energy was also used to heat up this water from 0 to 11.5 degrees Celsius. So in our experiment, what we're concerned about is the amount of energy that was used to melt the ice. Therefore, we can figure out how much energy this was, and we will subtract it from the 3,765. Because what happened here is the heat gained by the cold water, which is box number 10. So to determine this, we have to know, well, we know the temperature change, which was 11.5 degrees. We know the specific heat capacity of water as 1 calorie per gram degrees Celsius. So the only thing that we're missing is the mass of the cold water, which is the mass of the ice that we put in. So the mass of the ice was 43.21 grams. And so if we do the heat, which is the mass, 43.21 times 1 times 11.5 degrees, this is going to give us 496.9 calories. So this is the amount of heat gained by the cold water, 496.9 calories. So out of this 3,765 calories, about 500 were used to heat up the newly formed water to 11.5, which means that the remainder of the 3,700, right, which is ballpark 3,265, so the other 3,200 was used to melt the ice, and so that's the number that we need. So we're going to take our 3,765 and we're going to subtract the 496.9, and this is going to give us 3,268 .5 calories. So 3,268 calories was used to actually melt the ice. And since we have 43 grams of ice, the heat of fusion is the energy per gram. So we can take the 3,268, divide by the 43, and we get a heat of fusion of 75.64 calories per gram. With this number, we can calculate the percent error, which is the difference between our value and the actual heat of fusion of ice, which is 80 calories per gram. So if we do the difference between the two, we have the 75.64, and we subtract 80, which means our difference is 4.36, divided by 80, it gives us a percent error of 5.45%. I hope your results are good too.
I will, and, Ronnie's copy it.
And now we're ready to start the calculations for part 2 of our activity and specific heat capacity. So we're trying to identify an unknown metal, and to do that we need to calculate or to find its specific heat capacity. And then we're just going to compare it to some known specific heat capacity, and we're going to be able to determine what the metal is. So in order to do that, we had our calorimeter again, the styrofoam cup, and we put some water in here, and we plunged the piece of metal into the cold water. And so, of course, because the metal was hot, it gave some heat into the water, and the temperature of the water went up. And so by measuring the temperature change of the water, we can calculate the heat that the water absorbed. And we're going to make the assumption that the calorimeter itself did not absorb any of the heat. So therefore, the heat that the water absorbed is the heat that was given by the piece of metal. And so we can calculate, using this equation here at the bottom, that the heat that was lost by the metal is the mass of the metal times the specific heat capacity times the temperature change. Well, so the heat lost by the metal is equal to the heat gained by the water. And in doing so, we have all of this information that we collected in the lab, except for the specific heat capacity. So we're going to calculate in our data table. We measured the mass of the calorimeter and the mass of the calorimeter with the water. So we can subtract these two numbers here and get the mass of the water. So 92.87 subtract 10, we get 82.81 grams. And so the water started at 20 degrees, 20.33. And after we put the hot object into the water, it went up to 27 degrees. And so the temperature change of the water is from 20.33 to 27.07. So the difference between this, 6.74 degrees Celsius. So now we can calculate the heat that the water absorbed. So the heat of the water is equal to the mass of the water times the specific heat capacity of the water times the temperature change of the water. And so the mass of our water was 82.81 grams. The specific heat capacity of the water is 4.18 joules per gram degree Celsius. And the temperature change of the water was 6.74 degrees Celsius. And so by multiplying these numbers, we get 2333 joules. So this is the energy that is received by the water, and so therefore we say that this is the energy given by the metal. So it's 2333 joules. Right? And since the energy is given by the metal, it's a negative number. The metal loses this much energy. And this is equal to the mass of the metal times the specific heat capacity of the metal, which is what we're looking for, times the temperature change of the metal. The temperature change of the metal can be found because our piece of metal was initially in boiling water for over 10 minutes. And so the temperature of the boiling water was 100 degrees Celsius, which means that that was the original temperature of the piece of metal. And after cooling in the water, we determined that the end temperature was 27.07. So therefore, we can calculate the temperature change of the metal, which is a decrease from 100 to 27 degrees. So the temperature change of the metal is a decrease of 72.93 degrees Celsius. The mass of the piece of metal that we used was 84.98 grams. So we have all of the information. 84.98 grams times the specific heat capacity times the temperature change, which is negative 72.93, and this is equal to negative 2333 joules. So we solve for CP, and we get 0.376 joules per gram degree Celsius. So 0.376, and then we look back on the table and we find that that is probably zinc. I hope you were successful in this lab. Good luck.